Hey, good morning, good afternoon, everyone. My name is Josh Stepp. I work within the applications group here at Michael Weinig. Normally based out of the Mooresville office. Well, really based out of my home, but working out of the Mooresville office. So I am actually here with you guys today at Expo West. Going to be talking a little bit about panel processing on the Dynestic and how we use our internal software of EnVision and the kind of benefits of what it can do and how we see panel processing for sheet goods. So the first thing I kind of want to talk about is EnVision. EnVision is a post-processing software where you have full control over the design and the buildability of your cabinet. Is it bore and dowel? Is it cope and stick? For doors, is it going to be mortise and tenon for a door? Anything like that. EnVision lets you build anything. We're not geared towards we're only making cabinets or we're only making doors or we're only making, stair treads. It is an open-ended software that is fully user-controlled. And the way we do that is we do everything on a math-based system. So we do parametrics. And what parametrics mean is it is the study of how things are relational to each other. So if I'm talking about I want to drill a hole in, say, a cabinet door and I want it to always be 2 inches from the top. Well, using parametrics, I can say, and I'll go ahead and draw a little picture so it may make more sense. If I know I have a cabinet door, and it is, on average, we'll say 20 inches tall and 14 inches wide. So if I know I always want my first hole to be 2 inches from the top, my relation to that is going to be whatever the height of the door is minus 2 inches. So parametrically, if that door now becomes 30 inches, well, now I'm still going to take 30 minus 2, and it'll be at 28 now versus 18. And that, in a nutshell, is what parametrics is. So it's how holes and different machining is going to correspond to where it's at in the part. And because we do everything math-based, it's easier to determine that versus a design way. The other thing we can do with EnVision is we do what we call common line nesting. So a lot of people are used to conventional nesting. When you lay out your parts, it's going to create a pattern and put some type of toolpath space between them. What common line will do is we'll take a series of parts and we will try to combine them to where, we're going to share tool paths between them. And all that is done automatically. There's nothing on the user side of it that has to dictate how that's done. You simply tell it, I want to do this common line or I want to do it conventional whenever you're designing the part. And so upon doing that, you can get much faster nesting times and actually get faster production out of the same machine versus doing it conventionally. Also, there will be a little bit less tool wear because you're not going back and forth in the same spot. So what I'll kind of talk about first is going to be our software, EnVision that is, and then we'll go over and we'll run an actual nested cabinet, and I'll talk you through the process of that. For today's demo today, we'll be doing LockDowel construction. But with EnVision, we're not necessarily limited to a certain type of construction. We can do, bore and dowel, LockDowel, fasten link, etc. It's simply just instructions, and you're telling it what you want to do. So, if we want to build a cabinet, first we need to know the attributes of it. So, how tall is it? How wide is it? How deep is it? What type of material it's made of, etc. All those are going to be options that are given to the user in EnVision. So you will say this cabinet's going to be 36 inches tall. It's going to be 24 inches wide, 12 inches deep, made out of 3/4 inch white melamine. So all those are options. The minute something changes, because everything's done parametrically, we know how, if we always wanted to bore 1/4 of an inch into the material and we go from 3/4 to 5/8, we know how that changes based on parametrics. So what we'll do, if I can get Christian to pan over here, I'll kind of show you some stuff on the computer. We'll go through an order, and then we'll eventually step over to the CNC and run it. So what I have here is our EnVision program. So what we have is a graphical user interface to choose different items. So I have some cabinet doors, and what we'll do is we'll do our LockDowel upper. So like we talked about earlier, we get our options to choose. So I have a quantity. How many cabinets am I wanting to order? You know, what is the height of the cabinet? What is the width, depth, the case material thickness, the case material? If I wanted to do things like hinge hardware, finishes for if we're talking about solid wood stuff, which we get more into when we'll talk about the Weinig side later on this afternoon. All that can be options, and it's all fully defined by the user. So what I'm going to do is we'll order one cabinet at 36 by 24. So I'm going to go ahead and tell it to add. So what it's doing now is it's actually parsing through the template I've made and creating all the G-code for each individual piece on the fly. So we don't take one program and simply stretch it or anything like that. We're creating a unique program for every piece of the cabinet every time we order it. So if I look over here at my details, I can see I have a breakdown of all the pieces for that order. So what we'll go ahead and do is we'll make a little bit of a change to the width. We'll order another one. So once again, it's because of parametrics, we're scaling it down so I know how that top and bottom and those runners are going to be affected by shrinking the width. You know, the physical borings on the end aren't going to change. The only thing is going to be that X dimension of the part. So if we have our order here, what I'll go ahead and do is save. And so it's going to ask me if I want to save. I'll just say yes. And so what it's doing now is it's nesting. It's taking all those parts, it's putting them into a pattern to get the best yield it can on that sheet. And so doing that at the same time, we're also creating labels. Because when things come off the sheet, if we want to run something, you know, I need to be able to identify what it is after the fact. You know, so I can stick a label on it and either have barcodes associated to other processes downstream and then pass through other information. Like, you know, this is going to be a natural 36-inch long by 12.5-inch piece. That's the name of the program. There's the reference to what it actually is, the quantity. So the user fully defines the label. They can fully customize it to whatever they want. You can pass through whatever kind of information you want. Ultimately, you're in control of your whole process. So what we'll do, we'll go ahead and I'll have Christian pan around to me. We'll walk over here and I'll walk you through us running a sheet at the Dynestic and kind of talk you through what we're doing. Oh, hold on, let me. Got to make sure I don't drag my cable. Helping hands. So this is Octavio. He'll be running the CNC for me today. So if we can, we'll angle this and Christian kind of show what we're seeing here on the screen. So what we've done is we created a networked folder to where all our hops programs are going. So we have a nested base program here. Octavio will load, and so he can go ahead and drop it onto the CNC, and it will go ahead and create a nest of all our parts. The other thing we do is we add a ghosted script here, so it will tell you what type of material you're actually running. So there's no confusion when you're running different, you know, versions of melamine with possibly grain and color, what it needs to be ran out of. So all the machining is ready to do, and as you can see, this is a common line nest. So what we'll do is we'll go ahead and start it here, and we'll watch what's going on, and when it gets close to being done, we'll step up and look at some of the machining. So as you can see, what it's first doing is it's creating an onion skin. So it's going around and freeing the parts, but leaving just enough material to still keep it held. The next step it will do is I'll actually step in and do the machining for the LockDowel. And then finally, once all the machining for the LockDowels are done, we'll go through and we'll free the parts all the way out. And once they're done, we'll be able to show you what it actually looks like. So if I can get Christian to step up here, you can kind of see some of what the common line will actually look like. So as you can see, we got nice long tool paths that are all shared between parts. So what it should be doing here in just a minute is after it finishes this pass, we should be going over, we'll be putting the LockDowel tool in and moving out to do our machining there. So technically right now, the machining is done on the top, but only to a degree to where there's still actually some material left. And that is just so we achieve a nice uniform vacuum and able to hold the pieces down. Because the last thing we want is one of these pieces coming loose and either tearing up the machine or possibly even tearing up the material itself. You have the vacuum too to clean it when we're done. Make sure you get the top back too, so we can just clean the holes out. So it's fine. So right now it's finishing up doing the LockDowels. For this cabinet, I didn't actually have any shelving holes or any hinge brackets or anything like that. So it's just pretty straightforward. An upper cabinet with just LockDowel construction to mostly make a carcass. But this could be used, say, for like closets or something like that, where you're just wanting mostly like a storage area. So once it will finish machining the LockDowels here, we'll go over and we'll put the original bit back in to just finish cutting the onion skinning out and finally freeing the parts. So we're grabbing our final tool to go ahead and free the parts. So as you hear, there's not as much noise because there's very little material left down there that we're actually cutting and freeing away. But kind of like I was saying before, this is just one method for manufacturing. With EnVision, we're not necessarily geared towards a certain one or have any preference. Ultimately, it's up to you to decide what you want to do. So upon doing that, you know, if you would like more information or anything else like that to know about it, feel free to reach out to your local agent or anything like that. We're more than happy to do online demos specifically geared towards your type of product. Or to have you come out here to California or the Mooresville showroom, and where we can demonstrate this live in person for you, and you can see it ran on your own material or done, you know, on any type of machine you would be interested in. Right now it's a little uncomfortable in California. It's a little bit warm. Us larger guys don't like the heat that much, but you know, in a couple months, once it cools down, it'll probably be a lot better. So we're almost done freeing out our parts. And once it's done, I'll have Christian come up. We'll clean it out real good and kind of show you the fitment for the LockDowels. All right, so we're done. Octavia will go ahead and jog the machine. So if I can get Christian to come up here, we'll run a little bit of a vacuum, do a little bit of cleaning on the parts, and then can show the fitment. So as you can see, we get a nice uniform hole. Let me go ahead. Very little chip out or anything like that. So as you can see here, we'll simply go in and pretty much slide right down, just as easy as that. Once they're in, it's a little bit harder to kind of get out. Kind of tap free, but... And then everything, as you can see, is nested, separated from each other. And at this point, we could either apply our labels or, you know, take from here directly over to edge banding and finally assembly and be ready to go. Once again, though, if you guys have any questions about this process or how it's done, don't hesitate to contact your agent or your local Weinig Holz-Her representative, and we will be more than happy to talk you through this. So I'm going to go ahead and sign off, and then I will be seeing you guys here again in just a little bit when I will be talking through the solid wood side. So thank you.